Hello and welcome to Collab. This is our JAMB web series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2011. This is the first part of the recording. We are going to look at the first 25 questions. If you're new to this channel, please don't forget to subscribe to our channel, like and share our content. You can also visit our website at collab.com to practice the UTME exam and modular quizzes for free. Our first question here is on the paper type. Which question paper type of physics is given to you? In this recording, we are using the paper type C. Now this question is very, very important, okay, because it determines how your exam is going to be marked. So you should endeavor to pick the paper type that corresponds to whatever you've been given. Alright, if you pick the wrong paper type, that means that your answers are going to be marked against answers that are meant for, another paper type or a different set of questions, and that can greatly affect your results. So you should endeavor to check out for the paper type that you've been given and choose the paper type from what you have here that corresponds to it. Next question: on which of the statements above will pressure be dependent? The pressure in a liquid is given by H rho G, where this H here is the depth of the fluid or the liquid, rho here is the density of the liquid, and G here is the acceleration due to gravity. So if you look at this here, alright, and relate it to what we have here, so we have here density of the liquid, that is correct. Alright, so this is density. Depth below the surface of the liquid, that is also correct. The H here would mean the depth of that liquid. Okay, well, surface area, as you can see, is not featured here. Alright, the pressure in a liquid is largely independent of the surface area of the liquid. Okay, it is largely independent of the surface area of a liquid. This is in the case of a liquid, but in the case of a solid, okay, the pressure, let's say we have a body that is exerting a force at a point. Alright, we will say that the pressure exerted by that body at that point is inversely proportional to the surface area of contact, like to the area of that object that is in contact with the other object. Okay, this is with a solid. However, this question is about a liquid. So if we narrow it down to this question, let's narrow it down to this question. The density and the depth, okay, they vary directly with the pressure varies directly with the density and the depth. However, it is largely independent of the surface area of the liquid. So you have just I and I. Next question on work, energy and power. A carpenter on top of a roof 20 meter high dropped a hammer of mass 1.5 kilogram and it fell freely to the ground. The kinetic energy of the hammer just before hitting the ground is... Alright, so let's have some theoretical background on this question. Before that hammer was dropped, at that height where it was held before it was dropped, okay, it had potential energy. Now the moment that hammer dropped, the potential energy will be gradually converted into kinetic energy. Okay, then that hammer is going to have its maximum kinetic energy just before hitting the ground. Okay, it will have maximum kinetic energy just before hitting the ground, and the kinetic energy of that hammer just before it hits the ground is equal to its potential energy at that height where it was held before it was released. Okay, it's equal to its potential energy at that height. So instead of using the formula Ke is equal to half mv square for kinetic energy, instead of using half mv square, we'll be using the formula for potential energy. Okay, that is, we say the kinetic energy of that body just before it hits the ground is equal to the potential energy at that height. So we're using the formula for potential energy, mgh. So you have m, the mass, to be 1.5 times acceleration due to gravity, which is 10, times the height of that body above the ground, which is 20. Alright, so we have 1.5 times 10 times 20, and that is 300. Next question on law of motion. A man standing on a lift that is descending does not feel any weight because there is no gravitational pull on the man in the lift. Okay, there is no gravitational pull on the man in the lift, and the weight of the man is borne by the cord of that lift. Next, we have a diagram here. Okay, The diagram above shows two vectors at right angle. All right, that is perpendicular to each other, at right angle to each other, meaning the angle between those two vectors is 90 degree. The value of the resultant vector is, if you look at these vectors here, we can tell that this is force. Okay, why? From the unit here is Newton. That's the unit of force. All right, so we have two forces acting perpendicular to each other. How do we calculate the resultant vector here, or the resultant force here? A quick and simple way to do this is, when you have two vectors that are inclined like this, that are perpendicular to each other, okay, what we simply do is make this into a right angle triangle. How do we do that? We simply draw a line from here to here. Okay, just draw a line from here to here. So this will become a right angle triangle. The hypotenuse, the length of that line that you draw, the hypotenuse is now going to be the resultant of the vector. Okay, and so now we are looking for the hypotenuse, right? Like the resultant vector here. To do that, we'll be using our Pythagoras theorem. All right, so we simply say the hypotenuse square, that is this side here, square. Let's represent that resultant vector here as capital F. So we are going to have the resultant vector, that's F, capital F squared, equals the sum of the squares of this other side. The sum of the squares of this other side. So you have 6.0 square plus 8.0 square. 6.0 square, that's 36. 8.0 squared is 64. 36 plus 64, we have 100. So we have F squared is equal to 100. To get the value of our F here and remove this square here, we are going to take the square root of both sides. That is, we take the square root of F squared, that is F, the square root of 100, that is 10.0 Newton. So the value of the resultant vector here, or the resultant force here, is 10.0 Newton. Okay, on work, energy and power. If it takes an object 3 seconds to fall freely to the ground from a certain height, what is the distance covered by the object? Alright, so to solve this question here, we'll be using the third equation of motion. Alright, third equation of motion. If you recall the second equation of motion. The second equation of motion is S distance. The distance S is equal to UT plus half AT squared. S is equal to UT plus half AT squared. Now you can see that what we are using here is a little different from that, in the sense that instead of S we are using H here. The S in that equation is distance. H here means height. Okay. Another difference is, instead of half AT squared, we have half GT squared. Why? Because this body that is falling freely to the ground is falling under gravity. Basically, it's under the influence of gravity, meaning that the acceleration of that body towards the ground is going to be the acceleration due to gravity. So instead of using the regular A acceleration, we simply use G here, the acceleration due to gravity, because that body is moving under gravity. Now you notice that here, this UT here is out. Why? The body originally, before it began to fall, okay, its initial velocity at that point is 0, meaning the body was at rest to begin with, in the beginning, before it began to fall, before it began to like go down like that. So its initial velocity U at that point is 0. If you substitute that U here, you'll be having O is 0 times T, and that will be 0. So this part here is going to be out. You are going to be left with just this half GT square. Alright, so we can now solve for the value of our G and the time which we are given here to be 3 seconds. So you have half times G10 times 3 raised to power 2. Okay, the time is 3 and we have T squared there, so we have 3 raised to power 2. 1 over 2 times 10 is 5 times 3 raised to power 2, which is 9. 5 times 9, that is 45. Next question. So we have a diagram here that shows the position of a cone. The position that can be described as neutral equilibrium is represented as, alright, the cone here in X is in unstable equilibrium. We say it is unstable equilibrium, in that if you displace this cone a little, okay, this cone here is going to move further away from its point of equilibrium. In this position right here, we say that it is in stable equilibrium, in that if you displace this cone a little, meaning if you, let's say you push it a little or you tilt it a little and you release it, it will fall back to this position. Okay, so this is a state of stable equilibrium. Alright, but this Z here is what we call a state of neutral equilibrium. Okay, the cone here is in neutral equilibrium. Other cases have been cited here as well with the tennis ball, for example. So basically here, this position Z here is the cone here in this position is said to be in neutral equilibrium. Next, if a tube of small radius opened at both ends is placed in a liquid, the liquid is going to rise or fall depending on whether it's wet glass or it does not wet glass. Okay, depending on whether it's wet glass or it does not wet glass. Now, in the case of a liquid like water, for example, let's say you have a container with water and you put straw. Okay, you know straw that is used in taking drinks. You put straw inside that water. Okay, you will notice that the level of the water inside the straw is going to be greater than the level of the water in the container, because water wets glass. Okay, but if it were mercury, for example, that you had in that container and then you put a straw in it, you will notice that the level of the mercury inside that straw is going to be lower than the level of mercury in the container, because mercury does not wet glass. Whether a liquid wets glass or it does not wet glass is a function of what we call the force of adhesion and the force of coercion. Okay, it is a function of the force of adhesion and the force of coercion. What we call the force of adhesion is the force of attraction between molecules of two different substances. Okay, the force of attraction between the molecules of two different substances, while the force of coercion is the force of attraction between the molecules of the same substance. So what this means, like in the case of the water and that straw, for example, the reason why that water is like that in the straw is because there is a greater force of the force of adhesion, that is the force of attraction between the particles of that straw and the molecules of the water is greater than the force of attraction between the molecules of the water. What that means is that because there is a greater force of attraction between that water and that straw, the straw is going to pull the water to its side. Okay, it will pull it to its side, which is the reason why water, if you look at it in test tubes, okay, or let's say a burette or any kind of capillary tube, is going to form a concave meniscus. Okay, it will be bent down, it will form a concave meniscus. You can think of that as the tube pulling that water to itself. Okay, which is also the reason why its level will rise. But in the case of the mercury, it is the opposite. The force of attraction inside the mercury, the force of attraction between molecules of the mercury, like inside the mercury, is greater than the force of attraction between the mercury and that tube. What that means is that the mercury will kind of like pull itself away from the tube. Okay, so that's why you see it in the test tube or in any capillary tube. Basically, it will form a convex meniscus. It will form a convex meniscus. All right, so let us narrow it down to this question. I think I've answered this in the course of the explanation, that substance is going to fall below the liquid level if it does not wet glass. Like that mercury, for example, does not wet glass, so it is going to fall below the level of the liquid. Okay, it will rise if it wet glass, so this cannot be the correct option, and it will not remain the same. It will not remain the same whether it's no, it will not remain the same. It will fall below the liquid level if the liquid does not wet the glass. Next question on it. From the statements above, the qualities of a good thermometer are: a good thermometer should be sensitive, should be highly sensitive, meaning that it should be able to detect the slightest change in temperature. Also, it should have easy readability, it should be easy to read. Okay, it should be easy to read. It should also have an accuracy over a wide range of temperature. However, high thermal capacity is not a desirable quality in a good thermometer. Okay, because if it has high thermal capacity, that means it is going to have low sensitivity. It should not be very sensitive, because it means that it will require greater amount of heat to cause a rise in temperature. It will require greater amount of heat to cause a rise in temperature. So that will make that thermometer less sensitive. So the desirable qualities here are high sensitivity, easy readability, and accuracy over a wide range of temperatures. We have our website at Collab.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at Collab.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Alright, next question on machine. A machine is used to lift a load of 20 Newton through a height of 10 meter. If the efficiency of the machine is 40%, how much work is done? Now, the question is not very clear, in that if you're talking about the work done here, it could mean the work done by the machine, like the work, that would be the work output. The work done by the machine, that would be the work output. Or it could mean the work done by the user of that machine. Okay, that will be the work input, the work done by the user of that machine. So what we are going to basically do here is we're going to we look at both. Okay, let us calculate the work done by the machine and the work done by the user and see which of these answers we get is going to be in the option. So if you look at the work done by the machine, that will be equal to that. Also we also say that that is the work output or the work done by the load. It will be equal to the load times the distance moved by the load, and the load from the question here is 20 Newton. The distance by which it was moved is this height here, 10 meter. So you have 20 times 10, and that is 200 joules. So this is the work done by the machine. If we look at these options, we can see there is no 200 joules here. Alright, so that means that this cannot be. So that means what they are referring to in the question is not the work done by the machine. Alright, so then we will look for the work done by the user, the work input. To do that, we are going to be using the formula for efficiency. We say the efficiency E is equal to work done by machine over work done by user times 100%. The efficiency of the machine is given in the question as 40%, so we have 40 to be equal to the work done by the machine, which is what we've calculated here, 200 divided by, here we have represented the work done by the user by X, capital X. Alright, so this times 100%. So you have 200 over X times 100%. Now we do 200 times 100, that will be 200. Alright, that's 20,000. So you have 40 is equal to 20,000 over X. Now from here we can cross multiply this X here, so we get 40X to be equal to 20,000. Then to get the value of X, we divide both sides by 40. So we have X to be equal to 500 joules, and that's what we have. So we have 500 joules in the option. Which of the following could be effectively used to reduce friction? Greasing is one of the ways of reducing friction between two solid surfaces in contact. So other methods, other ways include the use of rollers and bearings. Streamlining the body as well is one way too. That is shaping the body into a form that will allow it to move easily. Boiling also reduces fluid friction. So we have grease from this. Next, on elasticity, a copper wire was subjected to a tensile stress of 7.7 times 10 raised to power 7 Newton per meter square. Calculate the tensile stress of the wire. We are given the Young modulus Z to be 1.1 times 10 raised to power 11 Newton per meter square. Alright, the Young modulus is equal to, the Young modulus denoted by this symbol is equal to the stress over strain. Okay, the tensile stress over the tensile strain. Now in this from here we have the tensile stress. If you give it the tensile stress, alright, and we have the Young modulus as well, we have to calculate the tensile strain. So you have the Young modulus equals the given tensile stress over strain. You can cross multiply this strain here, so you are going to have the Young modulus multiplied by the strain is equal to the tensile stress. To get the value of the strain, we then divide both sides by 1.1 times 10 raised to power 11. So we have this here. Now how do we do this division? We simply do 7.7 divided by 1.1, that will give us 7. Then times, we now use our law of indices for this, 10 raised to power 7 divided by 10 raised to power 11. Let's say I have 10 raised to power x, generally speaking. Let's say I have 10 raised to power x divided by 10 raised to power y. 10 raised to power x divided by 10 raised to power y. That will be equal to 10 raised to power x minus y. Okay, that will be 10 raised to power x minus y. So that is what we are going to apply here. Here we have 10 raised to power 7 divided by 10 raised to power 11. So that will be equal to 10 raised to power 7 minus 11. and that will be 10 raised to power 7 minus 11 is minus 4. So you have the strain to be 7 times 10 raised to power minus 4, and it has no units. Next, an object weighs 22 kg in water and 30 kg in air. What is the obtuse exerted by the liquid on the object? The obtuse is going to be equal to the difference in the weight, okay, the difference in the weight in air and in water, and that will be the difference in the mass times the acceleration due to gravity. So what is different in the mass is the mass in air minus the mass in water. Okay, the body is going to weigh lighter in water. So 30 minus 22, that is 8. 8 multiplied by 10, the acceleration due to gravity, that is 80 Newton. So we have 80 Newton here. Next, on heat calorimetry, a block of aluminum is heated electrically by a 30 watt heater. If the temperature rises by 100 degrees Celsius in 5 minutes, the heat capacity of the aluminum is, alright, the heat capacity is obtained from this formula here. So in this formula we have Q is equal to H delta theta. This Q here is the quantity of heat supplied. H here is the heat capacity, which is what we are looking for in this question, while this delta theta is the change in temperature. Okay, now from the question they said the temperature rises by 100 degrees Celsius. That is already the change in temperature. We are given like the change in temperature directly there. Okay, that is the temperature rise, is 100 degrees Celsius, and the time here is 5 minutes. We convert that to seconds by multiplying by 60. Okay, so you have 5 times 60, that is 300 seconds, and the power of the heater is 30 watts. Now where do all of this come in is this quantity of electricity is also given as PT, that is P the power times the time, and the power here is 30 watts times the time, which is 300 seconds here, equal to the change in temperature, which is 100 times H, and we have 100 H. 30 times 300, we have 9,000. So to get the value of our H here, we then divide both sides here by 100. So we have H to be equal to 90 joules. Next, a perfect emitter or absorber of radiant energy is the black body is a perfect emitter or absorber of radiant energy. Next, on matter, the phenomenon that shows that increase in pressure lowers the melting point can be observed in regeneration, okay, which is the process of solidifying by cooling, okay, where an object becomes a solid by cooling, by continuously losing. Next, if the volume of a gas increases steadily as the temperature increases at constant pressure, the gas obeys. That is what Charles' law implies. Okay, Charles' law says that the volume of a fixed or given mass of gas varies directly as its absolute or Kelvin temperature, provided pressure remains constant. So what that means, okay, what that direct variation means is that as the volume increases, the temperature increases. So as the volume increases steadily, the temperature also increases like that, okay, at constant pressure. That is Charles' law. Next, steam burn is more severe than that of boiling water because steam possesses a greater heat energy per unit mass due to the additional latent heat of vaporization that it possesses. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to write the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at collab.com, or you could also check it out in the video description below. Next question on electromagnetism. Which of the following types of waves needs a material medium for propagation? So waves can be classified into two based on the need for a material medium for propagation. We have mechanical waves and we have electromagnetic waves. Mechanical waves require material medium for propagation, while electromagnetic waves do not require material medium for propagation. Now the question is, which of the following needs or requires a material medium for propagation? So that is going to be a mechanical wave. So from this option, which one is a mechanical wave here? That is the sound wave. Okay, the sound wave is a mechanical wave. It requires material medium for propagation. In the other options, these are electromagnetic waves. They do not require a material medium for propagation. Next on it, the ground is always cold at night because the earth radiates heat to the atmosphere at night. Okay, it loses heat to the atmosphere at night, making it cooler, making the ground cooler, okay, or the earth cooler. Next on expansion, thermal expansion, a metal of volume 40 cm cube is heated from 30 degrees Celsius to 90 degrees Celsius. The increase in volume is by giving the linear expansivity of the metal as 2.0 times 10 to the power minus 5 per Kelvin. Alright, so the change in volume of that material is given as gamma here, which denotes the volume expansivity, times the change times the original volume times the change in temperature. Now why are we looking for the change in volume? Okay, because that's what we have to look for, the increase in the volume. Alright, now if you look at the question, we already have the original volume of the substance here, of the material here, which is 40 cm cube. The change in temperature, we can easily calculate it by taking the difference between these two. Okay, the change in temperature is going to be 90 minus 30, that will be 60. Alright, however, we do not know the volume expansivity. Okay, but we are given the linear expansivity. We can use that to get the volume expansivity. The volume expansivity will be equal to 3 times the linear expansivity. That will be 3 times the value of the linear expansivity, which is 2.0 times 10 raised to the power minus 5. 3 times 2.0 is 6.0 times this 10 raised to the power minus 5 here. So this is now the value, and mind you, this is per Kelvin. This is now the value of the volume expansivity. We can now substitute in this formula now. So the volume expansivity times the original volume, which is 40, times the change in temperature, which is 60. Alright, by the time you multiply all of this, 6 times 40 times 60, then divide it by 10 raised to the power 5, because this is 10 raised to the power minus 5. So that means you divide it by 10 raised to the power 5. You'll be getting is 0.144. Approximately, that will be 0.14 centimeter cube. Next, which of the processes above can be explained using the kinetic theory? The kinetic theory of matter can be used to explain the change of state, that is, the change in the phase of substances from solid to liquid to gas. We can use the kinetic theory of matter to explain that. We can also use it to explain diffusion and osmosis. Because in all of this, you can see that these things, they are kind of particulate. They have to do with particles. Okay, they have to do with particles. But radiation it has to do with an electromagnetic wave. We cannot explain that using the kinetic theory of matter. So that is out. So we only have I, and IV. Next on optics, when the human eye loses its power of accommodation, the defect is known as, that's what is known as presbyopia. Okay, presbyopia. It happens with old age. It's actually with old age. Alright, we have a question on sound wave. A length of wire has a frequency of 255 Hz when stretched by a force of 225 Newton. Okay, so it is 255 Hz and 225 Newton. If the force increases to 324 Newton, what is the new frequency of vibration? Alright, the frequency of vibration varies inversely as the tension in the wire or the stretching force. Okay, so it varies inversely as this. Now if you remember from Charles' law, we also have something like this. V varies directly. This is direct variation rather. Direct variation. So it varies directly as the square root of the tension. Now in Charles' law, we have V directly proportional to capital T. Then we turn that into an expression, into an equation where we have v1 over t1 is equal to v2 over t2. The same thing too is what we are going to do here. Okay, if we turn this into an equation, you are going to have f1 over t1 is equal to f2 over t2. So f1 here and t1 here means the initial frequency and the initial tension, which here is 255 and 225. So you have 255 over root 225 is equal to f2 is the new frequency, which is what we have to calculate, divided by the new tension, which is 324. If we square both sides of this equation in order to remove the square root, we are going to have 255 squared, which will be this, divided by root 225 raised to power 2 is going to give you 225. That square is going to remove the roots here. Okay, so you'll be left 225 equal to frequency square over, if we square this as well, you are going to have 324. That square will remove the roots here. So from here we can now cross multiply this 324. That is, here we have 65025 over 225 is equal to f2 squared over 324. We can use the numerator, the denominator here to multiply this numerator here. So you are going to have 65,025 times 324 divided by 225, and that is giving us 93,636. That is f2 square. To get the value of f2 and remove the square here, we are going to take the square root of both sides. So if we take the square root of this, we get f2, the new frequency, to be equal to the square root of this is 306 hertz. Okay, approximately. So you have 306 hertz. Next question, also on optics. A certain far-sighted person cannot see objects that are closer to the eye than 50 centimeters clearly. Determine the power of the converging lens which will enable him to see at 25 centimeters. Alright, the power of a lens measured in diopter is equal to 1 over the frequency. Okay, 1 over the 1 over the focal length of the lens or the mirror, and we are dealing with a lens in this case. Now if we use the lens or mirror formula, we have 1 over f, that's 1 over the focal length, is equal to 1 over the object distance plus 1 over the image distance. So this is going to be equal to 1 over the object distance from here is 50 centimeters plus 1 over 25, that's the image distance. If you take the LCM of 50 and 25, that will be 50. Then say 50 in 50 is 1 times 1 is 1, plus 25 in 50, that is 2, times 1 is 2. So you have 1 plus 1 is equal to 3 over 50. 3 over 50 is equal to 0.667. Approximately, you can say this is 0.0, this should be 0.07. But as you can see, the closest to what we have here is 0.06. So we just go with that. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Collab. Okay, like and share our content, and visit our website at collab.com to practice UTME exam and modular quizzes for free. Thank you.